on this. All right. So we define the level of significance. We call it alpha. This is the maximum allowable probability of making a type 1 error. So you cannot, just make a type 1 error beyond this one. And we said it is called alpha. It's a Greek letter. And the common values of alpha are 10%, 5%, 1%. But in the book, you could see some other values. It doesn't matter, but these are the common ones. Most studies and research and statistics are done at the 5%, which is a value in between 1 and 10%. Okay. Now, I told you when we perform a hypothesis test, there are going to be 5 steps. You are already familiar, just with the first step. The first step, guys, is to identify the null and the alternative hypotheses and state where the claim is, whether the claim is in the null hypothesis or whether it is in the alternative hypothesis. Now, how we're going to study the claim? This is what we're going to do. If it is a claim about the population mean, we're going to be giving, just some data from a sample, and you're going to be given X bar, which is the sample mean. We're going to try to convert, X bar to a Z score, which is, we call it the test statistic, which is called Z. And you are already familiar, just with the formula of Z, which is Z equals X minus the mean divided by the standard deviation. But when you work with X bar, guys, you have to change this one to sigma over square root of n, because as you learned in chapter 5, the standard deviation of the means will become sigma over square root of n. And based on this value, guys, we're going to extract what we call the p-value, which I'm going to define, just in a little bit. If you are doing a test about the proportion, you're going to be given the sample proportion, the percent, just from a sample, and you're going to be converting that to a Z-score as well, which is a test statistic. Now, this one, I said, guys, I'm going to make this section optional. I'm going to send you something via email, explanation, just of this section, and I'll have you, if you do, just the exercise that I'm asking you to do, you will get extra credit for this one. So that's going to be optional. So my focus is just going to be on these two, and these are going to be the highlight of section 7.2 to 7.4. I think you've seen that in the video yesterday. Okay. What is the p-value? This is big, guys, and I will explain that. So when we do a hypothesis test, guys, you have to start somewhere. Just like when someone goes for a trial, we assume that the person is not guilty and built on that. Either we can enforce, the fact that the person is not, a defendant is not guilty and acquit the person, or we can collect enough evidence, just against the person not being guilty and then convict, just the person. And the hypothesis test, is going to be working just like that. I think you've watched, just the videos. I'm going to have to assume that you did yesterday about, just the p-value. The p-value is a probability. It's a value between 0 and 1. And we find the p-value based on the fact that assuming that the null hypothesis is true. So we have to start, somewhere. So it is the probability of obtaining a sample statistics with values as extreme or more extremes than the one determined from the sample data. I will explain, just the p-value shortly. I'll have you just see a visual, just of that one. You've seen how it was applied, just in those short videos, but I'll show you, just a visual of the p-value in a second. The p-value is a value between 0 and 1. And if you can keep this in mind, p-value low, HO must go. If you remember that, this tells you that if you come up with a very low p-value, then you can reject the null hypothesis when we say HO must go. Because hypothesis testing, guys, is about making one of two decisions. Either reject, just the null hypothesis, or fail to reject the null hypothesis. And once you are able to make this decision, everything else, just would follow. And it's going to be all based, just on the value of the p-value that you get off your calculator. Now, when you perform a hypothesis test, guys, you could have two hypotheses that look like this. Do you guys still remember what did we call this one? A left tail test, a right tail test, or a two tail test? When it is a less than, we call it a left tail test. For a right tail test, it will be something like that, guys. The alternative should have the greater sign. That is a right tail test. And can someone tell me what do you think the two tail test is? What would the two tail test have?
Equal. Yeah.
Equal or not equal?
Equal.
When I say not equal to 5, the mean is not equal to 5. I'm saying it could be more than 5 or less than 5. Either way, that's why we call it, just a two tail test. Okay. For each claim, state HO and HA and determine whether the hypothesis test is left tail, right tail, or two tail test. A school publicizes that the proportion of students who are involved in at least one extracurricular activities is 61%. That means equal, guys. So if you write this one, it will be P equals 61% and P not equal to 61%. And this is called, guys, a two tail test. Now he's asking you to visualize, the p-value. If you have a two tail test, guys, the p-value, it's going to be some area shaded on both sides of the tails because it is a two tail test. So that would be the p-value right here. And technology is going to help us, just find this p-value. Now, a car dealership announces that the mean time of an oil change is less than 15 minutes. That's a greater than or equal, less than 15. And you guys, you agree with me, this is a left tail test. And this is how you sketch it. If he asks you show the p-value will be an area to the left because it is a left. So that would be the p-value here. It's an area under the curve. A company advertises that the mean life of its furnaces is more than 18 years. So as you can see, guys, I'm giving you all the scenarios of the p-value. The nice thing about the calculator, it will be able to visualize, graph this for you and show you the p-value. So you guys agree with me, more than 18 should be here. That's the claim. And less than or equal to 18. And then the p-value will be an area to the right. That is the p-value right here. Okay, how do we make decisions based on the p-value? You will be given alpha, which is the maximum allowable probability of making a type 1 error. And you compare the p-value with alpha. Alpha is a value between 0 and 1, and the p-value is a value between 0 and 1. If the p-value is less than or equal to alpha, you reject the null hypothesis. And if the p-value is more than alpha, what would you think the decision would be, guys? Then you what? Fail.
To reject HO.
Reject HO. I want you to memorize this, guys. You're going to keep it with you at all the time because you're going to need this. Every single problem you do in this chapter and the remaining chapters, you have to use this fact. You're going to get a p-value, and then based on whether p-value is less than alpha or greater than alpha. And that's what I said, guys. P-value low, HO must go. P-value less than a small number, then HO must go. Then you reject HO. Now, let's say your claim is in HO, turns out to be in the null hypothesis, and you reject HO. What do you tell a reader? How do you state your conclusion? You state that you have enough evidence At the very end, guys, you are studying a claim, whether you're going to be able to support the claim or not support the claim. So if your claim is in the null hypothesis, guys, and you end up rejecting the null hypothesis, what do you say about the claim?
You reject the claim.
Exactly. There is enough evidence to reject the claim because the claim is a part of the null hypothesis. That's very good. So this is a language that we will be using, guys. You will see that later. So if the claim is in the null and you reject the null, you reject the claim because you're rejecting the null hypothesis. So reject everything in the null hypothesis, including the claim. Now, what would you say, guys, if the claim is in the null hypothesis and you fail to reject the null hypothesis? Then you state that there is not enough evidence to what?
Reject the claim.
To reject the claim. I don't have, you're not saying you're accepting it, guys. The word, you cannot speak in support of the claim if it is in the null hypothesis. So you say either you reject it or you don't reject it. That's it. There is not enough evidence to reject the claim. And you're going to notice, guys, this will be the standard language. We're not going to change this language. It's if it makes sense to you now, it should make sense in every single problem. Now we're going to do other scenario. If the claim is in the alternative, and this is where it should be most of the time. So if your claim is in the alternative hypothesis, guys, so you have HO and you have HA, and the claim is here. And you reject HO, what can you say about the claim? This is bad.
You can support the claim.
Exactly. There is enough evidence. You state that there is enough evidence to support the claim. You see, guys, we're using the word support now because the claim is in the alternative. There is enough evidence to support the claim. And I guess you guys know what's going to come up next. If the claim is in HA, but you end up failing to reject HO. If you guys cannot reject HO, that means you cannot support the claim because you're saying I cannot reject number one. How can I support number two? Because you have to make only one decision. You can't say both are good because these are total opposite of each other, guys. If you say that this is not bad, then you cannot say that this is good. So you just say that you don't have enough evidence to support the claim. So this is what I tell my students, all the time I teach, not just this chapter. If I tell them, if you end up with failing to reject HO, you start your conclusion with there is not. So fail means not enough evidence. 2. Now, when you go, just to your book online and do your homework, you're going to see a drop-down menu. It's going to say support or reject, and students get confused here. So students will ask me, Mr. Bazzi, what can we do, here to make sure that we pick a right word? I tell them, where is the claim? They tell me the claim is in the alternative hypothesis. Then I tell them you have to put the word support here. And we're not saying we're supporting here, guys. We're saying we don't have enough evidence to support. That means we're not supporting.
So the word support work with the HA claims and the reject works with the HO. We reject or fail to reject.
Perfect summary. You got it. Exactly. Don't use the word support when the claim is in HO. When the claim is in HO, guys, you use the word reject or not reject. When the claim is in HA, you use the word support or not support. Exactly what you said. Yeah. Okay. We're getting there. We're getting to the first question. We haven't done, it's all introductions, guys, now. You perform a hypothesis test for the following claim. How should you interpret a decision if you reject HO or you fail to reject HO? A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So let's write them down first. P is 61% and HA P is not 61%. So you guys, you agree with me how important step one is? You need to know where the claim is. Sorry. You need to know where the claim is. They say is 61%, so this is where the claim. Okay. If you reject HO, what do you say, guys? You say there is enough evidence to what? Can someone tell me?
To reject.
Reject the claim by the school. And then you can write what the claim is. That the proportion of students who are involved in at least one extracurricular activity is 61%. If you fail to reject HO, guys, you start. As I told you, fail, start with there is not. Period. Enough evidence that there is not enough evidence to reject the claim by the school. And for the reader, guys, at the very end, they want to know, are you supporting or not supporting the claim? That's what they need to know. So this is step number 5 that we're writing right here. Okay, let's do another one. A car dealership announces the mean time for an oil change is less than 15 minutes. Let's write them down first. So less than 15 minutes, guys, is this. And mean greater than or equal to 15 minutes. And this is where the claim is, as you can see. Okay, if you reject HO, what do you state? Would you guys agree with me? If we reject HO, we say that we support the claim. That's HA here. So there is enough evidence to support the claim by the car dealer. And if you fail to reject HO, guys, what would you say here? There is not enough evidence to support the claim. We don't have enough evidence to support the claim. Steps of hypothesis testing. We've done this already. You already know how to make this decision. If the p-value is less than alpha, we reject HO. If the p-value is more than alpha, we fail to reject HO. We've done this already. These are the examples. What do you say after you make a decision to reject HO or fail to reject HO? Yet, just to show you how to do those. And the good news is we're going to be using technology to do them. But I'm going to show you how to do them first, just by hand, and then we'll be using technology right after. All right. These are, guys, just for you, just to learn how to use the order of operation, just when using the calculator. These are from step 2. So I'm not gonna do them, well, probably I'll just do one of them and show you how to use the calculator. Okay, just 1 second. Let me grab my calculator. So how would you enter this into your calculator? This is what you do, guys. Open parentheses, 110. I mean, as students could say, I can do 110 minus 105 first. Yeah, you can do that. But if you want to do it in one shot, here's how you do it. And here, open parentheses, 12 divided by, now we need the square root, guys. You can see it right here. Second and square root of 35. Get out of the square root. This is how you get out of the square root, with this. Close parentheses. And here you go. That is 2.47. I'll have you try the rest, just on your own. Interpreting the p-value. The p-value for hypothesis test is 0.0237. What's your decision if alpha is 0.05? So do you guys agree with me that 0.0237 is less than 0.05?
Yes, so
What's the decision? Reject or fail to reject?
reject, right? If
Yeah.
p-value is low, HO must go.
You got it. Here you go. I have one student who picked this up already. Now, some students will ask me, how low is low? Lower than alpha. That's how you compare it. You compare it with alpha. So we should reject the null hypothesis. Okay, let's check.
So, Professor, that means we failed to reject the alternative?
If the claim is in the alter, yes, very much so, exactly. You'll end up supporting the alternative, yes. Yeah. Let's see the next one. Okay, now if alpha is 0.01, look what alpha makes a big difference, guys. Now alpha is 0.01. And do you guys agree with me? If alpha is 0.01, our decision is going to be reversed. 0.0237 is bigger than 0.01. You agree? So what would be the decision here?
We failed to reject, or?
To reject HO, exactly. Exactly. All right. Now, let me tell you we're gonna sketch, just the p-value in a second, and I'm gonna do it, just from this exercise right here. Example 13. The first example in section 7.2. Let's begin with an example and show you the 5 steps. In auto racing, a pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. Does everyone agree with me that the claim will turn out to be in the alternative hypothesis, because less than should be assigned in the alternative hypothesis? So less than 13, and I put the claim there. Now he has to give me data from a sample or information from a sample, a summary of data from a sample, and ask us to study this claim. So he says, a random selection of 32 pit stop times, so N is 32, guys, has a sample mean of 12.9. You guys agree with me, this is X bar. Assume that the population standard deviation is 0.19. So it's a Z distribution, not T. Once he give you sigma, just like in chapter 6, guys, so we'll be using, just normal, standard normal distribution, Z, sigma is 0.19. Is there enough evidence to support the claim? And look, he gives you alpha, guys. He says alpha is 0.01. Okay, let me walk you through the steps. That was in the video from yesterday, guys, but I kind of feel that I just have to go over it, just before we do something else one more time. So step number 1, I think everybody agree on that. We've done a lot of work, just on the first step. Although I'm not going to require you, just to do the step 2 and 3 by hand, but I'm just going to do it, for the first time by hand, but then later we'll see how the calculator does that. Step 2, guys, we need to transform this value, X bar, to a Z-score. And I gave you the formula just earlier. This is the formula. That is the formula. So X bar, guys, we know it's 12.9 minus. We assume that the null hypothesis is true until proven otherwise. So we're going to take the value of 13 from the null hypothesis because it has greater than or equal to 13. You put 13 divided by sigma. Sigma is what, guys? 0.19 over square root of n, which is square root of 32. And let's use the calculator to do this. This is why, guys, I put this expression earlier and I asked you to use a calculator to find it. Something similar to this, as you can see. So put 12.9 minus 13. And just bear with me, guys. You're not going to have to do this by hand, but just let me show you that what we do by hand is programmed into the calculator. 0.19 divided by square root of what? 32. Watch. Okay, I got negative 2.98. Z-scores are rounded to 2 decimal places. So negative 2.98. Step 3, which is the p-value. And let me show you what the p-value is. I'm going to show you a visual of the p-value. Okay. You draw the standard normal curve. Okay. Is this a left tail test, a right tail test, or a two-tail test, guys?
Left tail.
Left tail test. That means the p-value is an area shaded to the left. But what is the starting point of this area? It's the z-score that you found in step 2. So you put z equals negative 2.98. And by definition, the p-value, guys, is the probability of having a value that is as extreme as negative 2.98 or more extreme. More extreme, guys, when you're doing left, it goes to the left. More extreme when you are on the right, it will go to the right. So the p-value is the area to the left of negative 2.98. If you have a left tail test, it will be the area to the right if you have a right tail test, and it will be the area on the right and on the left if you have a two-tailed test. And guys, from chapter 5, you should be able to help me find the area to the left of negative 2.98. How do you find the p-value? From your
Inverse
not inverse norm, it's an area.
Normal CDF.
Normal CDF. Okay, go ahead.
Negative 1 million.
Negative 1 million. Here you go. You still remember. Negative 2.98, comma 0, comma 1. Remember, this is 0, and that's a Z line. Okay, let's do it and see what we come up with. And again, guys, you're going to see that you don't have to do this to find the p-value. It's going to be done automatically later, just in few seconds. But let's see. So second distribute, normal CDF, negative 1 million. I think it's going to be a very small p-value, although I shaded too much, but this is just a sketch. Okay, I got 0.0014, 4 decimal places. Okay, are we good so far, guys? So step 1, step 2, step 3 is the p-value. Step 4, make a decision to reject HO or fail to reject HO. And remember, alpha is 0.01. Just remember that. So let's compare in step 4. There you go. Step 4. P-value is 0.0041. 14, I'm sorry. Do you guys agree with me that this is less than alpha? How do I compare? 0 equals 0, 0 equals 0. Here I have a 0, the second digit after the decimal, here I have a 1. So this is less. So what's your decision, guys? Reject HO. Step number 4, guys, is about the null hypothesis only. Don't even think of the claim. It's whether you reject the null hypothesis or fail to reject the null hypothesis. Because the p-value is less than alpha, you just reject HO and proceed to step 5. Okay, step 5, guys. The claim is in HA, and we reject HO. So what do we say? There is what?
Enough evidence to support the claim.
You got it. There is enough evidence.
Like the 1%.
You have to mention the significance level. Very good. At the 1%, because you have to tell the reader that you're not 100% sure. There is a chance that you've made a mistake. There's a 1% chance of type 1 error here. So at the 1% level of significance, to support the claim that, and I'm just going to copy it and paste it. The pit crew mean pit stop time is less than what was it, 13 seconds. So their claim is valid, and people who want to hire them, they can go ahead and hire them because we supported their claim that they can change 4 tires and refuel in less than 13 seconds. This is a typical example, guys, of a hypothesis test, how to perform a hypothesis test. Now, let me show you that we could have avoided, just all of this work and done this in one shot. Watch. You ready? It's a Z test. And you ask me why is Z not T? Because he gave us sigma, the population standard deviation. So you turn the calculator on, you go to stat, you go to tests, and you go to Z test, first test, section 7.2. It's a summary, stats, okay. The mean, okay, mu0 means is asking you to put in the value from the null hypothesis, enter the value in the null hypothesis, which is 13. Sigma is 0.19, X bar is 12.9, N is 32. And now the last step, guys, before you hit calculate or draw, he wants to know, the calculator, the program wants to know what is the sign in the alternative hypothesis. Not the claim, the alternative hypothesis. It happened to be the claim here. So you select it. You have an option to choose the color. And I'm going to show you a draw here. What you're going to see, guys, you're going to see a visual of the p-value along with its value NZ. So what the calculator does, it will give me step 2 and 3, and that's all I need to make it 4 and 5. So watch. Okay, Z is negative 2.9
Question.
and P is 0.00. So probably I didn't round it properly there. It should be, well, no, 1.4, that's fine. 0015. Any questions?
Yeah.
Yes.
Tells you invalid dimension. DIM, what's that mean?
Oh, you got an error, I'm assuming.
Yeah, I did.
Yeah, it's yeah, you got an error. Just probably you have something in there. You just go to y equals, and if you have anything there, just try to delete it. Yeah, but you should not get this one. But if to avoid just getting this error right now, even if you don't delete that, look what you can do. Z test. Instead of hitting draw, you hit calculate. And guys, you get the test statistic, which is negative 2.98. Does anyone know a reason why the calculator is giving us 0.00145 and we got 144 for the p-value? Both answers are correct, guys. Do you know why the calculator, just value is different from what we got when we did the normal CDF?
Because we rounded the Z.
Thank you. Very good answer, because we rounded the Z score. Exactly. And the program online, guys, will take this into account. So you don't have to worry about it, whether you do it by hand or using technology. Now, one other question I want to ask you guys before even I move to another one. When I did draw, you didn't see the p-value, although I did show you a p-value right here on the left. Why didn't you see anything on the left here, guys?
Because it's so small.
Thank you very much. Excellent, guys. Because it's so small, you're not going to be able to see it. It's only 0.0014. I did just as a visual, guys, I make it show. I'm not going to do it. It's just like technology, because you need to see that there is a p-value. The only reason why you guys didn't see it, because it's too small to shade. All right.
And then the symbol, when you were choosing that for when you were just punching it in, it was in reference to the HO, right?
Let's see. Let me go back. What is it?
At the U, the symbol. I'm trying to see if it was in reference to HO or HA.
All right, right here.
Yes.
Yeah, no, a reference to HA. Whatever HA is, just use that.
Okay.
All right. Good
Got it.
question, guys. Very good questions. All right, let's see. All right. I guess just 1 second. We're gonna go to the next. So for a left tail test, the p-value is area to the left. Right tail test, p-value is area on the right. And for two tail test, it's on both. You just compute the area in one area and multiply the answer by 2. And let's just do an example now, guys. Find the p-value for the left tail hypothesis test with a test statistic z equals -2.23. So can you guys tell me how do I find the p-value using normal CDF? I'm just gonna write it down here. It's
Negative
a left tail test, -1 million.
negative 2.2301.
Excellent. Okay, let's see what the answer is. Second, distribute. He might ask you some questions in the homework without giving you a hypothesis test just like this. So that's why I decided, just to put something similar. But most of the questions that you're going to be working with, guys, are hypothesis testing. So it's 0.0129. Would you reject the null hypothesis or fail to reject the null hypothesis if alpha is 0.01? What do you guys think? Compare this with that. Do you guys agree with me this is bigger than alpha?
Yes.
And then what's the decision?
Fail to reject.
Fail to reject.
Fail to reject HO. Very good. Find the p-value for a two-tail test hypothesis test with a test statistic of z equal 2.14. Okay. The p-value, guys, is going to be twice the area because it's left and right. Can someone help me? Normal CDF.
2.14.
2.14.
1,000,001.
Yeah, and then 0.1, exactly. Okay, let's find it. So I'm gonna do distribute. And you understand why we multiply by 2 because we have two tails here, just for two tails test. And then 0.1. So I got 2 times 0.0162. Let's times it by 2, which is 0.0324. Okay, what do you think, guys? Comparing it with the 0.05 here.
Smaller.
Smaller.
We reject, right?
Reject HO, exactly.
So there's examples like this on our homework.
Yes, just a few, very few, maybe one or two, but mostly hypothesis test. This is the formula that I use, guys, to find the test statistic. We'll put it right there. And I'm gonna go to a next question. We're ready to do another complete one now. We'll be using technology. According to a study, the mean cost of weight loss surgery is $21,500. You think this information is incorrect? First of all, guys, I would like to state the null and the alternative hypothesis. Help me out. It's you who's making the claim that this is not correct, and you want to study this claim.
Alternative would mean is not equal to 21,500.
Excellent, excellent, very good. Because you're saying this is not correct. That means not equal to 21,500. That's the claim. This is what I like, you guys. This is the approach that I like you, not just to think of, just when trying to figure this out. Just see who's making the claim and follow the claim. It says not incorrect means not equal to. And now let's see what he's given us to study the claim. You randomly select, just 25 bariatric surgery patients. So N is 25. And find that the average cost of their surgery is 20,695. That's the mean from the sample. The population standard deviation, guys, he makes it clearly that this is a population standard deviation sigma. It's 2250. And the population is normally distributed. He has to tell us that the original population is bell-shaped because the sample size is less than 30. Is there enough evidence to support the claim? So either you say there is enough evidence to support the claim or there is not enough evidence to support the claim at alpha equals 0.05. Okay, you're ready, guys? Just, if you know what you're doing, this problem will take only 2 minutes, just to process. Watch. Stat, tests, z-test. Mu0. What goes under mu0, guys? Can you tell me the value?
21,500.
You got it. And then sigma, I'll just move to the other side, guys. Sigma is 2250. X bar is 2695. I would review, guys, what I enter on the screen just before you hit the calculate, just in case if you missed anything or you made a typo, because I wouldn't be able to know what you did, guys. And then
Professor,
yeah?
where'd you get X bar from? I can't see it on the problem. Is it
Oh,
on
it's
the other
right there.
behind the calculator?
You randomly select 25 and find that the average cost for their surgery is 20,695.
And how we always get the mu0, the first value you enter?
From the null. Whatever you put here on the right-hand side is the value.
Always from the null.
All, because remember, we have to assume that the null hypothesis is true until proven otherwise. So we have to assume equality before we assume that it's not equal later.
Oh, and then regular mu is from the HA, correct?
Exactly, exactly.
Okay.
You can memorize it this way, fine with me, guys. Yeah, what you're thinking of is correct. Let's hit the draw and see. Hopefully that there is a p-value big enough you can see it, guys. And you guys agree with me that on the graph, if there is, the p-values has to show on both sides because it's a two-tailed test. Watch. There you go. Okay. So Z is step number 2, negative 1.79. You agree? And p-value, guys, let me copy it. 0.0736. You see how much time does the calculator saves us? It gives us the 2 steps that require most of the work. Done. If I ask you guys, can you estimate this area alone here? What would you say this area is?
-2.
No, this area. The red area.
Half of P.
That's not
Wasn't
P.
it like 2.35% or something like that? I'm trying to
No,
remember.
but you already have the p-value. You have both of them. How much is one?
Half of
Oh,
it.
half of it.
Half of it, exactly. So this is 0.0736 divided by 2, and this is 0.07.
Professor,
Yes.
when I do that on my calculator, I don't know why I get a box and whisker plot, a 5 summary one as well.
That's what. Well, I'll see me after class. I can fix this one. No problem.
Okay.
No problem. We'll fix it. No problem. All right. So now we're comparing to alpha, guys. Do you agree with me that this p-value, which is 0.0736, is bigger than alpha, which is 0.05?
So
Everybody?
is this step 4 or still on step 3?
No, we're in step 4.
Oh, 4.
Yeah. And what's the decision, guys, when p-value is more than alpha? Fail to reject HO. Now the final step. Write, just your conclusion in the context of the claim. So you start.
There's not enough.
There is. I'm just gonna change colors here, guys. Not enough evidence at the 5% level of significance to what, guys?
Reject.
No, the claim is in HA.
Oh, to
Support.
yeah.
There's
So
not enough evidence to support the claim that the cost of weight loss surgery is not 21,500. So we believe it is still 21,500 because we could not support it is different. All right. Okay, let's just leave this part, just for tomorrow. This is another method of doing hypothesis testing. I'm just going to focus on the p-value for now. So this is a second example, guys, in how to use the p-value approach, just to test a claim. Next question. Number 3. Employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than that of one of its competitors, which is $68,000. They're making the claim that they are getting paid less than their competitors, which is $68,000. How would you state the claim, the null and the alternative, guys?
the null is that it's equal to 68.
They're claiming it is
Less,
less.
less than. The claim is in the null.
Claim is an alternative. It's the mean is less than 68,000.
The mean, do you guys agree with that?
Yeah.
And you guys, this is the claim. They're claiming that they're getting paid less than 68,000, which is what their competitors get. I know a student say equal because he probably or she read the word is, but that's not what their claim is. The claim coming from the mechanical engineer who are saying that we get paid less than our competitors. And your alternate null, guys, will become this. And that's the claim. Okay. Well, those engineers, guys, better have a good case, when they present that to their supervisor and tell their supervisor that we think that we're getting paid less than their competitors. They have to do a study. So that's what they did. A random sample of 20 of the company's mechanical engineers. So N is 20. Has a mean salary of 66,900. X bar is 66,900. Assume that the population standard deviation is 5,500. So sigma, guys, is 5,500. And the population is normally distributed. At alpha equals 5%, test the claim. All right. He has to give you alpha, guys. So do you guys agree with me? Because he gave you sigma, you conclude right away it's a z-test. That is a z-test. All right. Let's run the z-test. Watch. Stat, tests, z-test. I don't have data yet, so it's just stat summary. Okay, mu0, you would have to put the value from the null hypothesis. We assume it is 68,000. And then I'll go to the other side. Okay. Sigma is 5,500. X bar is 66,900. N is 20. And now we have to choose the sign from the alternative hypothesis. You guys, you can see it's less than. So you choose less than, and then hit calculate. You want well, let me show you what you see in calculate. If you do calculate, it doesn't matter. You can do both. I'm going to show you both. Okay. All we need those two steps, guys. Step number 2 and step number 3. And let me do it, just with the shade. I like to see the p-value in action myself. Okay. You can see why the p-value shaded on the left, because it's a left tail test. So z is negative 0.89. And the p-value is, let me copy it. You see, it's not low. So HO is not going to go anywhere. 0.1855. Step number 4. You guys agree with me that the p-value is bigger than alpha. So fail to reject HO. And then step 5. Okay, you're gonna help me with that. There is, since we fail, we start with not enough evidence at the 5% level of significance. You have to tell the reader that you are using a level of significance here. There is a chance that you mistakenly reject HO when it is true. That's a probability, that's a level of significance alpha to what? There is not enough evidence to support the claim, exactly. Support the claim by the mechanical engineers that they earn less than 68,000.
This is pretty much section like 7.2 and 7.4.
Very much the same. It's going to be, as I told you, it's going to be a continuation. So you guys, do you think the supervisor or the manager should give him a raise or not?
No.
No, because they could not, if you guys want something, you better be able to support it, just with the evidence. They could not provide the evidence. We're not saying they're wrong, but probably the sample they picked didn't work out well for them. They have to pick probably a different random. So that's how that works. Any questions, guys, so far?
Mr. Baz, yes, please. Just the last step on the calculator was the claim value, like the HA, if the claim in HA or
No,
in
not
HO.
of the claim. No, not of the claim. What HA is. The last step we have before you hit calculate. Let me just go back. All right. Okay. This step is just what is the sign in the alternative. I don't care whether the claim is there or not. We don't care. It's just a sign. And look.
The alternative sign.
The alternative sign. And don't worry whether it is the claim. It could be the claim. It could not be. It doesn't matter. It's just. All right. Okay, let's do some more exercises. And just 1 second. So we're moving to section 7.3 where sigma is unknown. And as you learned in chapter 6, guys, when sigma is unknown, we use the sample standard deviation instead, and we use a distribution called T distribution. So your test statistic will be called T now, not Z. Better, and we're doing exercise 22 on page 384. A company claims that the mean battery life for their MP3 player is at least 30 hours. Let's write them down, guys. How do you write the null and the alternative? Number 22. You want to help me how to state those?
Well, the claim is in HO because they're saying it.
Exactly. So page 384. Number 22, HO. At least it says, at least guys, 30 hours. Do you guys agree with me that at least it's more than 30? And that's what the claim is. And you guys can write the alternative now, which is going to be less than. You suspect the claim is incorrect and find that the random sample of 18 MP3 players has a mean battery life. Okay. So N is 18. They have a mean battery life of 28.5. X bar is 28.5. I'll move the book on the side, guys, once I get the sample data from there. And a standard deviation of 1.7. He didn't say population standard deviation. He says the standard deviation from the sample. So what sample do I use for the standard deviation here, guys?
S.
Exactly. That's the key, guys. This is where you need to distinguish, whether you use z-test or t-test. They're not the same. Is there enough evidence to reject the claim? And look, guys, he's asking you, is there enough evidence to reject the claim? He didn't ask you if there is enough evidence to support the claim, because the claim is in HO. And when the claim is in HO, he cannot use the word support. He has to use the language of rejection there. So we know for sure that the claim is in HO here, which we did. We put it already in HO. So that will be a t-test, guys. And let's perform that test. So you understand the transition, guys, because sigma is not known, S is given instead. We have to use a t-test. And let me show you the t-test. So you go to step number 2, t-test, and watch. I have a summary. I don't have the data. Okay, mu 0, just like you did, guys, before, 30. X bar, which is 28.5. You see here, it says S. It doesn't say sigma, so it is S, 1.7. N is what, 18? And can someone tell me which one before we hit the draw? First, second, or third?
Second.
Second. And make sure, guys, to select it and press enter. Sometimes it blinks and you think it has been selected, but probably it's not. It just make sure to go there and hit enter to select that. And let me just.
So whether t-test or z-test, you're always getting the mu, standard mu from HA, correct?
100%.
Okay.
That's what you're gonna like about this, guys. There is consistency throughout, that nothing changes there. Okay, I'm drawing the p-value now. It's a small, as you can see, a little bit of shading.
I got 8e -4.
Okay, let's see what the.
Yeah, me too. I got 8e -4.
No problem. No problem. We're going to interpret that. So let me write step number 2 and 3. So -3.7. Usually the test statistic T is 3 decimal places, guys. So it's -3.744. And let me write what I got from the p-value on the calculator. I'm just going to copy it exactly. Okay, let me tell you how you interpret this. E -4 means 10 raised to the power of -4. That means you have to move the decimal point 4 digits to the left. And you ask me, where is the decimal point? It's sitting right there. So if you move this 4 digits to the left, what would that be, the number?
0.00008.
Yep, that's the number. And let's see what alpha is. I didn't read what alpha is. Alpha is 0.01. Okay, so that's step number 1. That's step number 2. That's step number 3. And step number 4, guys. Do you guys agree with me that, when you see E, right away is your p-value almost 0. It's less than alpha for sure. So you guys agree with me that this p-value, which is 0.0008, is less than alpha. So we reject what?
HO.
Remember, the claim is in HO. So what we're gonna say here, there is enough evidence at the 0.01 level of significance to what?
Reject the claim.
Very good. To reject the claim. And then you can copy and paste the claim, guys, that the mean battery life of the MP3 player is at least 30 hours. I'm gonna write it down. That, I mean, you have to write for a reader. Tell them what the claim is, that the mean battery. I don't know if anyone uses MP3 player anymore. So the claim of the company is wrong. We can reject their claim. But they're lying to us. Okay, so that's an example of 7.3, and let's do another one. I want to pick one that where the claim turns out to be, guys, in the alternative hypothesis. So let me just select another one. Okay, 24. Lead levels. As part of your work for an environmental awareness group, you want to test the claim that the mean amount of lead in the air in the US cities is less than 0.036 microgram per cubic meter. Okay, guys, I'll pause for a minute to just have you write, the null and the alternative, and then we'll compare them. So just take a minute and write them down. He says less than 0.036, so that's where my claim, and the other sign will be greater than or equal to. And let's continue on reading, guys. You find that the mean amount of lead in the air from a random sample of 56, so N is 56, cities is 0.039, so X bar is 0.039. microgram per cubic meter, and the standard deviation is 0.069. S is 0.069. At alpha equal 1%, can you support the claim? All right. It's a t-test, guys. As you can see, there is S here, so it's a t-test. And I'm ready to find the step number 1, 2, and 3. You already put step number 1 down. So just go to the calculator, stat, tests, t-test. Okay, mu 0, 0.036. X bar is 0.039. S is 0.069. N is 56. And can you guys tell me which one do I use before I hit draw or calculate?
Second.
Second one, very good. And let's do a draw. A calculate will be faster, a lot faster. Let's do a calculate. Okay, T is 0.325. And look at the p-value, it's huge. So you're not gonna be able to reject HO. Only when p-value is low. You can see the p-value, it's big, 0.6269. Okay, more than alpha. What's the decision, guys?
Fail to reject.
Yep. Fail to reject HO, and then you start. There is not enough evidence at the 1%, 0.01 level of significance. Sometimes he gives you that as a decimal, other times he uses a percent, it doesn't matter. At the 0.01 level of significance to support the claim. We're not supporting the claim, we're saying we don't have enough evidence to support the claim. And then you can copy and paste, just what the claim is. The claim that the mean amount of carbon monoxide in the air in US cities is less than 2.34 parts. Which one did I? Oh, right here. Is less than 0.036 right here. All right, so that's another example. Now we're going to do an example, guys, where you have to enter raw data into your calculator to perform a hypothesis test. So let me just get this example. And it's on page 385. Class size, number 29. You receive a brochure from a large university. The brochure indicates that the mean class size for full-time faculty is fewer than 32 students. So they claim that they have less than 32 students. Well,
So
first,
the claim is HA,
yes, exactly.
and then HO would be greater than or equal to.
Correct. So let me write it down. And let's see if the school is right about their ad, about their brochure. So you get suspicious and you want to study this claim. That is how you start, guys. I cannot emphasize enough how important the first step is. It's very important. You want to test this claim. You randomly select 18 classes. I'm going to show you the data in a second, guys. Taught by full-time faculty and determine the class size of each. The results are shown in the table at the left. At alpha equals 5%, can you support the claim? All right, guys, here you go. There's the data. So let's do, go to L1 and put your data in L1 right there. So this should go to L1. Now let me pause for a second. So again, guys, this is a t-test. You enter the data in L1. We're going to go to tests. T-test. Data. This time, guys, you don't have a summary. You have the actual data. So you're going to select it. And what goes in here, guys?
Would that be 32?
Correct.
Or
Yeah. No, or that's it.
but what about frequency? What do we put for that one?
Always one.
Oh,
Never
okay.
change it. Just put a note for yourself. I should not change this ever. And what goes in here, guys? Before I hit calculate or draw, first, second, or third?
Second.
Second.
And I agree, guys, with you. And then hit calculate. And here you go. So here we choose input. I'm gonna just put it for you guys, data. And let me just write the conclusions that we have. So we got T is negative 1.943. P-value, just write it like that. P-value is approximately 0.0344. And what do you guys think? Is this bigger than alpha or less than alpha?
Less than alpha. So we fail to reject?
No,
Or
it's less. What do we do? P-value less than alpha, then HO.
oh, we reject it, right?
Yeah.
HO gotta go.
You said that early. Stick to it.
All right.
I know it's confusing. It is confusing, but guys, with time, you'll get used to it. You should just repetition, you should get to it.
Yeah, the only steps I like kind of are like iffy about is the last two, 4 and 5, but it's just the interpretations.
Yeah, that's very important. That's why we're studying statistics, to interpret results. So there is enough evidence. So look, if you reject HO, let me repeat again and slowly. If you reject HO, you start with there is enough evidence. And then you mention the significance level now at the 0.05 level of significance. And let me give you the hint again. Now, two. If you're doing this in my math lab, your system is gonna give you a drop-down menu to choose reject or support. Because your claim is in HA, guys, choose the word support. To support that the whatever the claim is, mean class size, the mean. So there it's a true claim. The mean class size for full-time professors is less than 32. That's the conclusion of the problem. Okay. Just to give you a feel, guys, of what we'll be heading toward tomorrow. So this is section 7.3. And if you just allow me, we have 5 minutes and I'm not gonna use much just to show you here how different things are gonna be in section 7.4. Let me just show you an example, a quick example. Okay, number 15 on page 392. I'm going to show you the transition, guys, is not bad. It's very much, we're doing the same. A humane society claims that less than 67% of US households own a pet. How would you write the null and the alternative, guys? Remember, we're talking about percents now, no longer average, the mean. So what would you put? What letter would you use now?
B.
B. And do you guys agree with me? Less than 67% and greater than or equal to 67%. And where is the claim? He claims that less, exactly, HA. Very good. You see, no change. No, it's just same concept as we did in the previous sections. In a random sample of 600 US households, 390 say that they own a pet. So N
is 600
and X will be the number of successes, just like in confidence interval, guys, the same thing, exactly, 390. At alpha equals 10%, is there enough evidence to support the claim? So alpha is 10%. Can we support the claim? Okay. This is not a mean test, so it's not a Z or T, it is a proportion test. And guys, let me show you where the proportion test is sitting right here. Look, this is a Z test, a T test, and you can see number 5 is your proportion test.
Number 5?
Yeah. You don't pick interval, it's a proportion test. Okay. And let's do this one.
Four, you said?
Number 5.
So 67.67.
67.67. Exactly. And then X is 390. Then N is 600. And which sign do I use, guys?
The second one, I think. Yeah.
Second one, that is correct. And bingo. Draw. The p-value is the same idea of the p-value right here. Ooh, big p-value, guys. Too much shading. So Z is negative 1.0504.
Hold on, question.
Go
I
ahead.
get a domain error.
We're gonna, I'll fix that right after we're done. You shouldn't, but I'll fix it. Just stay, don't sign, don't just sign out once we're done. I'll show you how to fix this one. So in this case, this is what I like you to do, just to get the same results as we did. Don't do the draw, just do the calculate, and you should be fine.
Yeah, I'm doing calculate. It's giving me error.
Oh, the calculate is doing the error right here?
Yeah. Oh, hold on. Let me do
Should it?
0.67. Hold
Yeah, make sure to enter 0.67, not to just 67. It might not like it as a percent.
Yeah, correct. That's correct.
Yeah, negative 1.04. And look what the p-value is, guys, 1487. And you guys agree with me, this is bigger than 10%. So what's the decision? Not the conclusion, decision. Who can tell me the decision?
You're gonna reject HO.
To reject HO, I agree. And guys, if you fail to reject HO, we start with there is not. Anytime you have fail, then you start with there is not enough.
Evidence to support the claim
Exactly.
at 10%.
There's enough evidence at the 10% level of significance to support the claim. And you can say what the claim is.
The claim is P is
Less than 67%.
yeah.
At the 10% level of significance to support the claim. And you don't need to figure out, just the claim or language, just copy it and paste it from the question itself. That less than 67% of US households own a pet. So this is, we will continue, just to do more